Hi everyone, this video is going to walk you through all the problems of the 7.1 through 7.3 quiz review. If you're just looking for a copy of the answer key, just to reference and check, there is a copy of it posted on Schoology, but this video will give you an explanation as to how each and every problem in this review actually works. So we're going to start with the graphing problems from section 7.1. You'll notice I've already filled in the XY table and I've already plotted the graphs because I would say 95% of you are in good shape in terms of how to pull that from the calculator. The only thing I'm going to caution some of you on is making sure that when you sketch the graph, it should look exactly like what you see on your calculator screen. Don't add more, don't get lazy with the sketch and just have the lines kind of trail off wherever you want them to. Sketches should match what you see on your calculator. So numbers 1 through 4, you can see what's there in terms of the graph itself. The one point I want to emphasize with each of those is the domaining range. Now, square root functions are going to have a more specific domaining range because they have starting points rather than just going infinitely left to right, up and down. We do have to pay attention to where they stop and start. So, our domain for the first function, as far as in terms of going from left to right, the leftmost value is 4, and since it's included, we use a bracket, and then it goes infinitely right, and then we'll put a parentheses after the infinity. For the range, the lowest value is 0 on the y scale, and that is included on a point, so we use a bracket. It points upward to infinity, and we put the parentheses after that. The second example is pretty much the exact same thing. We see the starting point here, so I'm looking for domain as far left as the graph goes. The leftmost point is a 0, and we use a bracket for the included point, and it points right, therefore going to infinity. The range, the lowest value is at -1, with it going upward to infinity. So with a square root function, you do need to pay attention. Domaining range, this is where you're going to use the bracket for something with one of those included points, because again, you do have a starting/stopping point on the graph. For these cube root functions that you see in numbers 3 and 4, these are the easy ones, because a cube root function, for what you need to know, is always going to go left to right infinitely, down to up infinitely, no matter how it's stretched. So my domains and ranges are going to be the exact same thing. -infinity to positive infinity in both cases. So I'm going to go ahead and put that in for both answers here. Make sure you don't randomly switch the order of these. In grading the one worksheet from a couple days ago, some of you were putting the positive infinity before the negative. Remember, it has to be in number line order. So -infinity has to come first, then the positive infinity. So that kind of takes care of the graphing aspect. That was from the first section, 7.1. Now what we're going to take a look at are a lot of the concepts from 7.2, which was starting to use some of those radical and exponent properties, which is what a good chunk of your quiz is going to be on. So you're going to get a couple really basic questions like you see here on numbers 5 through 8, where I'm going to give it to you problem in one notation. You need to convert it to the other. So 5 and 6 are both written in exponential, they're both written currently in radical notation. We need to change it to exponential notation. All I have to do, so in number 5, I have the cube root of 4a plus 5, all taken to the 4th power. I'm going to pull out the 4a plus 5. If you have more than just a singular number, put it technically in parentheses because it all needs to stay grouped together with the power. Pull out the 4a plus 5. The exponent that's out front is the top number of your fraction. The root is the bottom number of your fraction. And that's written in exponential notation. Notice I'm not doing anything else with it. We're not going to magically pull a number out of this and punch in the calculator. We're just simply rewriting it. That's it. So number 6 is the exact same idea. You've got 10m. That's going to be taken to the 2/5 power. Again, the exponent will go on top. The root will go on the bottom of your fraction. So I can do the reverse order of that. So if I give it to you in exponential notation, I can go backwards and write it as a radical. Remember, the bottom number of the fraction, if I'm going backwards, means that's the root. So this would be the third root of 3x. Technically, you can write this to the first power, or since the first power doesn't really do anything, it leaves it as the same term, you could just write this as the cubed root of 3x. In the 8th example here, I can put a second root of 7k. risen to the 5th power. Remember, a second root is the exact same thing as a square root, so the more efficient way to write that, you don't need the 2. You definitely need the 5, however. Remember, in the world of radicals, when you have the root symbol, 2 is the invisible number because that's the lowest root you can possibly have. So you could write it with the 2, that's not a big deal, or you could just remember that it's a square root, and that's good to go. So that's how you convert between the forms. Again, pay attention to how you're writing stuff. Make sure if you're writing exponents that they're clearly raised up. If you're writing radicals, make sure that the roots are clearly within the check mark portion of the radical sign. Make sure you are writing things properly, otherwise they could technically represent other things. So just be careful, be neat in how you're writing this stuff out. So the next chunk is you'll get a couple of problems where you'll have to evaluate the expression that's given without a calculator, which, again, you will have your calculator with you, but that means you're going to show me some work, and then you'll get a problem or two where you're just simply going to punch it in the calculator, tell me what decimal spits out. So if we look at numbers 9, 10, 11, 12 here, these are the ones that, if I'm telling you to show some process, these are the ones that are going to come out pretty nice. So what this often means is that we're going to take all these exponents here, we're going to convert them into radical notation. So I'm going to start with 81 to the 1/4. I'm going to convert that first to the 4th root of 81 to the risen to the 1st power. So again, if you've picked up on some of these number patterns, you should be able to do this pretty easily mentally. If you haven't quite picked up on some of these basic numbers that you get with like 3rd roots, 4th roots, etc., it's fine for you to use your calculator and punch it in, but I do want to see this little bit of process showing me that you can at least show the work. So if I take the 4th root of 81, it comes out to 3, and 3 to the 1st power remains 3. Do the same thing in number 10. So 27 to the 5/3, I can rewrite as the 3rd root of 27 to the 5th power. The 3rd root of 27 is 3, and you take that to the 5th power, it comes out to 243. Number 11, 64 to the 4/3 power. That means that is the 3rd root of 64 to the 4th power. Cube root of 64 is 4. You take that to the 4th power, you get 256. Now the last one here, this is going to use a little bit of exponential properties that we talked about within the last couple of days in class. This is a negative exponent. Before I rewrite this, I need to do one quick little thing. Anytime you have something with a negative exponent, remember, it has to change sides around a fraction. So what I'm going to do is rewrite this as 1 over 343 to the positive 2/3. Negative exponents have to become positive, and then all of a sudden we can do the same work that we were doing. It's just now going to be in the denominator of a fraction rather than in the numerator of it. So, same steps. I'm going to now rewrite 343 to the 2/3 as the cube root of 343 squared, which will give me 1 over 7 squared, which gets me 1 over 49. So again, you can use your calculator to certainly verify all of this stuff. That's not really going to be an issue. Even in the directions, it'll say, show your work to get your answer. I need to see steps. If you just give me the number, you won't get the point for it. So make sure you can rewrite the form, show the little bit of PEMDAS, if you will, to get the correct answer. Now, the ones underneath. Now, why I have 6 of these in here, I'm not really sure, but this should be ample practice to make sure you can punch in these type of problems just in the calculator and get whatever spits out of it. So, with these numbers here, you're going to get, for the most part, pretty gross answers. So, if that happens, again, round to 2 places with whatever answer that you get. So, with these here, all we're going to do is you're going to punch it in like I've taught you in class. Tell me what it spits out. So just to quickly run through the answers here. 4th root of 567 comes out to roughly 4.88. The 6th root of 192 comes out to roughly 2.40. Cubed root of negative 216, that one's actually nice. It comes out to negative 6. The 7th root of negative 256 comes out to negative 2.21. 27 to the 3/2 power comes out to 140.30, and 14 to the 2/3 power comes out to 5.81. So again, all you're doing is just punching that in your calculator. Again, review what we talked about in your notes from the last couple of days. Remember, I'm not going to be there for your quiz to walk you through the steps on how to punch this stuff in. This is stuff you do have to know how to do on your own. So if you don't know how to do this, look in your notes or Google or something to figure out how to punch this stuff into your graphic calculator. So some of the basics there with your properties, how to rewrite the different notations, how to punch stuff in the calculator, how to use your calculator to evaluate, all that good stuff. Now let's take a look at and review some basic equations, because you will get one or two of these guys. So we're solving. Remember, when we do solving, we have to pay attention detail-wise in terms of what type of exponents and roots we're dealing with here. Because remember, if we're dealing with some even roots, we're going to be dealing with that old pesky plus minus sign, so we need to account for that in our answers as well. So again, that only applies for even roots, so we'll come across those here in a second. So let's start with number 19. X to the 7th equals 200. Not a whole lot to do here. If I want to get rid of a 7th power, that means I got to take a 7th root. So I'm going to take a 7th root to each side, which will get x by itself. Again, odd numbered root, so I just need whatever the calculator spits out. No plus minus here. If I take the 7th root of 200 in the calculator, rounds off roughly to 2.13. So that's all I have to do for that. Very basic, very quick equation. Some of the equations, again, will come out gross. Some of them will come out nice. You get what you get. And that will be the same case, too, on your quiz. Number 20, a little bit more math that we have to do here. So I'm going to go ahead and subtract the 5 to start. And I'll get x cubed equals 512. To get rid of a cube, I'm going to cube root, which means x will be by itself. The cube root of 512, this one comes out great. It comes out to 8. Number 21, first thing I'm going to do is divide away the 3. Okay, so x to the 4th being multiplied by 3, I need to make the 3 go away first. Okay, some of you made that mistake on the worksheet from the other day where you took the root first. Keep in mind, when you solve an equation, you do backwards PEMDAS. So we got to get rid of anything that's being added or subtracted, then get rid of anything that's being multiplied or divided, then get rid of the exponents, or roots in our case. So we're going to get rid of the 3 by dividing it away. We'll get x to the 4th equals 27. Now we'll take the 4th root of each side. This is an even numbered root. So the fact that I'm taking it, I've got an even numbered root here, means I'm going to use my plus minus sign. The 4th root of 27 is approximately 2.28, positive or negative. And finally, 22. So here I have an expression locked in parentheses to the 6th power. So x plus 1 to the 6th equals 4096. Since everything's locked in the parentheses there, I do have to get rid of the exponent first. So again, I'm going to undo it by taking the 6th root, leaving me with x plus 1 equals even numbered root. Here comes my plus minus sign. 6th root of 4096 comes out really nice. It comes out to 4. So in this case, x plus 1 will equal plus or minus 4. Subtract 1 to each side. We'll get x equals negative 1 plus or minus 4. Since these are two nice, easy numbers, we're going to go ahead and solve them. So we're going to go ahead and add them and then subtract them, which means you'll get two answers of 3 and negative 5. So that's how you go ahead through and figure out, solve some of these basic equations. We'll do more stuff with this later on in this chapter, but for what you need to know right now, this is the level that we're looking at here. So you'll see, I believe, one or two of these on your quiz as well. So that takes you through section 7.2. The last chunk of the review is going to take you through what we've done Tuesday and Wednesday in class, section 7.3, which was all those exponent, all those radical properties, how to simplify, maneuver things around, etc. So let's go ahead and take a look at how to simplify all this stuff. So let's take a look at 23 and 24, mostly focus on just putting exponents together and all that good stuff. So when we want to simplify things, the biggest things you need to make sure of are that you've got positive exponents and that you combine all the like bases. So problems should not have multiple x's in them or multiple y's or multiple 7s or whatever the case may be. Everything has to be combined as far as you can take it. So let's take a look at number 23 and how we would combine these things together. So first thing that I see to do is we've got a power outside of something risen to a power. I'm going to distribute that in, and it's going to be x to the 3 times 1/2 over the x. So I'm distributing that power in because that's what you do when you have a power outside of something in parentheses. And we're going to go ahead and simplify that. So that would come out to x to the 3/2 over x. I still have the same base top and bottom. When you have the same base over top of each other, you subtract the exponents, top minus bottom. Keep in mind, if I just have an x, it's the exact same as x to the first. So all I'm going to do now to combine my terms is take the 3/2 minus 1 and come up with a final answer of x to the 1/2 power. Number 24, we've got a similar looking problem here. We've got 2 of the same base on top of the fraction and then the same base on the bottom. If I have 2 of the same base on the same side of a fraction, I add my exponents together. So I'm going to go ahead and take p to the 3/2 plus 5/3 over p squared. Now again, you don't necessarily need to show out all these little steps of work, but again, more just so you can see what properties I'm using and how I'm just putting all the exponents together rather than just magically showing up with some answers here. So again, show as much as you need to, but this is how we're combining everything so you can see every step. So I've got 3/2 plus 5/3. Keep in mind, if you're going to do this by hand, you need common denominators in order to add those fractions together, or use your calculator and convert it to a fraction like you've been taught before in class. The numerator is going to turn into p to the 19 over 6 power over the p squared. Just like the last problem, I have the same base on top of each other, so I'm going to go ahead and subtract those exponents. So I'd have p to the 19 over 6 minus 2. You subtract those together. Again, this will come out to another improper fraction. P to the 7/6 power is your final answer there. Now, number 25 and 26, we're going to have some radicals here, and we're going to do some different things with these. A lot of what you're going to see on your quiz is what you see in this review, which is very radical heavy. It won't be as many exponents. But number 25, there's a reason I put this in here because you might see it again tomorrow. We've got 2 radicals inside parentheses. Now, typically, if you have 2 radicals, you try to combine them and do what you can. The problem with them is you can see that there are 2 different types of radicals. We have a 4th root and a 5th root. That might be a little bit tricky. That's a little tricky to combine because they're not the same root. You can't just magically mash them together. However, one thing that we've talked about in this chapter is that roots are the same thing as exponents. So what we can do instead to maybe make this easier, so I'm going to write a little note in here. The roots aren't the same. Okay. However, we're going to write them as exponents. So based on what we've talked about in the section 7.2, the 4th root of x is the exact same thing as x to the 1/4. The 5th root of x is the same thing as x to the 1/5. So I'm just going to simply rewrite my problem. From here, this is actually easier to combine because you do have the same base. And that's what allows you to kind of rewrite and finagle this to actually go somewhere with it. When they're written as radicals, you really can't combine them as they are because they're not the same. But remembering that radicals and exponents, you can just rewrite things. Now all of a sudden, you can use your exponent properties to combine things and make things work. So, a couple ways you can do this. What probably most of you will end up doing is distributing your exponent. So, x to the 1/4 times x to the 1/5, and we distribute that 20 to both exponents. So I would have x to the 24ths times x to the 25ths, which simplify really nicely x to the 5th times x to the 4th. When you have the same base in a line like that, you add your exponents, and it turns into x to the 9th. So that problem is a little bit trickier, but again, there's a reason why I kind of stuck that on there. So that is something you might see tomorrow. So keep in mind, if you have different roots, and I'm not saying you're going to see 100 problems like this. At the most, you might see 1. If you have different roots, make them exponents. And all of a sudden, it should be a lot easier to put together. Now let's talk about 26. So we've got ourselves a square root of 63n to the fourth. Keep in mind, we know it's a square root because I don't see a number inside the little checkmark portion of the radical sign. Therefore, we're going to look for pairs, okay? So don't confuse this with the cubes and the fourth roots and all that kind of stuff, okay? This is like you've learned for the last couple of years in math. It's just a square root. We're just going to look for pairs of things. So we're going to break apart the 63 into 7 and 9. 9 becomes 3 and 3. If you want, we can break the ends apart if you want to draw that out visually. So we're looking for pairs. I see a pair of 3s and 2 pairs of ends. All the pairs come out front. All the leftovers go under the root. The only leftover I have is a 7. I would combine what's out front by multiplication. So that becomes 3n squared times the square root of 7. So with square roots, I'm going to be looking for pairs of things. You'll definitely see a problem or two with a square root. So that's just going back to older knowledge, but it's stuff you certainly know how to do because, again, we're just grouping things into pairs, pull the pairs out, leave the leftovers underneath the radical. Now we get into some bigger roots. So I have the fourth root of 50 times 5, the fourth root of 100. Now, unless you can come up with the fourth root of 50 or the fourth root of 100 off the top of your head, you might want to mess with this problem a little bit to try to combine stuff. So what we're going to do here is I'm going to rearrange this problem a little bit. So I got the 5 out front. I'm going to take those fourth roots and combine them together. 50 times 100. Because when you have the same root, you can just combine whatever's underneath them together, whatever the operation is. So I'm going to rewrite this as 5. So the fourth root of 50 times 100 is 5,000. I'm going to take that 5,000, split it apart. What we are looking for, since it is a fourth root, we are going to look for 4 of a kind. So I'm going to split it back apart into the 50 and the 100. 50 turns into 5 and 10. 10 turns into 5 and 2. 100 becomes 10 and 10, which gives me another couple sets of 5s and 2s. So what I'm looking for out of this is I need 4 of the same prime number. I see 4 5s. Okay? So they're not next to each other, but that's okay. I still see 4 of them in these trees. So what I'm going to do is this. First off, there was a big 5 that was already out front. We're going to write that first. I have a 4 of a kind of 5s that I can pull out. So I have one 4 of a kind. I'm pulling that 5 out. I don't have any other 4 of a kinds, so everything else is a leftover. I see 3 2s left over. Those 3 2s are going to go back underneath my root. I'm going to combine. Outside's going to be 25. The fourth root of 8 will be underneath. And that is my final answer. So again, fourth roots, we're looking for 4 of a kind when we have to break stuff apart. 28 is pretty much the exact same problem. The only difference is we're dealing with cube roots. If I'm dealing with the third root, we're going to look for 3 of a kind. We're going to look for triplets. So I'm going to do the same exact thing I did in 27. So I have a big 3 out front. It's going to stay there. I'm going to combine the 48 and 12. So keep in mind, you can leave these separated like that and make your trees from here if you want. If it's easier for you to visually put them together than re-break them apart, it's really up to you. I'm going to just put them together so I'm consistent with the last problem. So 48 times 12 gets me 576. So we can break this apart. Again, you can break it back apart into 2 numbers that are there. It's up to you. And we're going to keep going. So 48 turns into 6 and 8. So 6 is 2 and 3. 8 is 2 and 4. 4 turns into a couple more 2s. 12 becomes 2 and 6. 6 becomes 2 and 3. So I'm looking for triplets. I need 3 of a kind. Okay? Every triplet can pull out as one big group out in front of my radical. So I see 3 2s and another 3 2s. I have 2 triplets of 2s. So out front of my radical, I'm going to have that 3 that was originally there, the first triplet of 2s, the second triplet of 2s. No more 3 of a kinds, so we're going to open up the root. I see 2 3s that are left over. So I'm going to put the 2 leftover 3s underneath. Then I'll simplify. So out front it'll be 12. Underneath the cubed root it'll be 9. my final solution, is 12 times the cubed root of 9. So that's how we look at how to simplify. Again, just putting a couple roots, multiplying them together. Now we're going to take a look at some of these that require some division. Now, again, not saying they're going to have to do crazy amounts of work. We did some problems, as you may remember, on Wednesday with that took several steps. I'm not saying you're going to see ones that are always that difficult. Look at the information you have, and again, you might luck out and see problems that simplify really easily or cancel really quickly. So let's take a look at 29. I have the cube root of 5 over the cube root of 8. What you should try to do is simplify each thing first. If it can simplify, you might be able to end this problem pretty quickly. So cube root of 5 is not going to break apart. Cube root of 8, however, look at the way that breaks down. 2 and 4, and then the 4 breaks down a couple of 2's. I've got myself a triplet of 2's. This problem's done before I know it. Top stays the same. Cube root of 8 is 2. If your root goes away in the denominator, that's when you're finished. So maybe it's as simple as it simplifies right off the bat. Maybe you have to rationalize. It just depends on what kind of number you're dealing with in the bottom. Okay? But you cannot have a root in the denominator. We have to make sure that simplifies itself out. But that's it. 30, similar problem, except we're dealing with square roots. So again, I'm going to look at square root of 5. I can't break that down. But 125, I can break that down to 5 and 25. 25 becomes 5 and 5. I have a pair of 5s I can pull out, so I can rewrite this. The top's the same. The bottom, I can pull out that pair of 5s, and I have a 5 left over. Now, could we see a root in the bottom? So your initial reaction might be, well, we need to rationalize it and multiply and figure some stuff out. You certainly can do that. However, you have a root 5 on the top and a root 5 on the bottom. They can cancel out, leaving you with a numerator of 1, a denominator of 5, and no more roots. 1 over 5 would be your final answer to that problem. So those first couple right there, they simplified pretty quickly. You didn't have to rationalize anything. What you'll see in 31 and 32, you might have to do a little bit of rationalizing, and you'll see that here in just a moment. So let's look at 31. You've got cube root of negative 2 over cube root of 4. So if I break apart the denominator, we have 2 and 2. So I have 2 2's. In order to break and make that radical go away, I need 3 of the same number. So if I already have 2 2's, if I can get one more 2, I'll make the radical disappear. So what I'm going to do is multiply it by just that, the cube root of 2 over itself, because I need that third 2 to make things break apart. So all I'm going to do is multiply straight across, so the top will be cube root of negative 4 over cube root of 8. Top's not going to change, but the bottom turns into a 2, and you've got yourself a final answer. 32 is the same idea. There is just a little bit more in terms of terms. We've got some variables mixed in here, and we're going to go ahead and try to break stuff apart here. So again, my goal is to simplify both top and bottom as far as I can, and then whatever I have to do from there, I'm going to do. So in the top, we have 5n cubed, cube root of 5n cubed. We can't take the cube root of 5, but we certainly can take the cube root of n cubed. The cube root of n cubed just turns into a regular n. So out front, I can have an n with a cube root of 5 left over. So that'll simplify up top just a little bit. In the bottom, kind of the same idea. So we can't take the cube root of 9, and I have a gut feeling that'll be a common mistake that can be made. But square root of 9 we can take. Cube root of 9 means when you break it apart, you have 3 and 3. Remember, you need 3 of a kind. We only have 2 of that number, so that doesn't quite break apart yet. The n cubed, however, if I take the cube root of n cubed, once again, it's just another n that comes out front. So putting it with the 3 that's already there, 3n out front, cube root of 9. So once I simplify those things as far as I can, so again, I have a cube root in the bottom, I can't do anything with it, so I got to rationalize it. So we've already established 9 breaks apart into 3 and 3. I need a triplet because it's a cubed root. To get that triplet, I'm going to need one more cubed root of 3 and that'll magically make the radical disappear. So I multiply that. So up top I'm going to have n cubed root 15 over 3n cubed root 27. Right now my top's going to stay the same. The cubed root of 27 is 3, so I'd have 3 times 3 times n. Now, to simplify this, there's two things we're going to do. We know 3 times 3 makes 9, so we'll fix that here. But we have an n on top and an n on the bottom. The n's will cancel out, leaving you with a final answer of the cubed root of 15 over 9. The last bit of this is doing stuff with addition and subtraction. So the key again with addition and subtraction is that you need the same radicals, the same type of exponents, and the same bases in order to combine things. The numbers out front, the coefficients in front of those things can be different, that's fine. But you must have cube root of 20 and cube root of 20. They have to be the exact same thing, otherwise you can't add or subtract them together. So if you look at the first couple of examples here in 33 and 34, these are going to be easy to combine because they all have the same type of root, and they're all taking the root of the same thing. So in 33, all I'm going to do, they all have cube root 6. 2 plus 3 minus that invisible 1. This simplifies to 4 times the cube root of 6. And that's it. 34 is the exact same idea. They both have cube root of 5. All I got to do is 2 minus 3. So I can write negative 1 times the cube root of 5. And that's all finished. So where it gets a little bit trickier, problems like 35 and 36, because in 35, we're taking the cube root of two different numbers. So I can't just mash that together and call that cube root of 105. That is very wrong, and don't do that. We have to try to get them so that they are like radicals, and in order to add them together. So when you do this, the biggest thing I suggest is do one term at a time. Don't try to do both at once because you'll mishmash the factor trees and probably pull numbers from the wrong spot. Do one at a time, simplify each separately, and then add them together. So I'm going to take cube root of 24 and break it apart into 8 and 3. We know how 8 breaks apart. I've done that already 100 different times. I have myself, again, cubed root. We're looking for triplets. I've got a triplet of 2's. So out front, I'm going to have negative 3 times 2, cubed root of the 3 that's left over. Now I'm going to do the same thing with the other term, do 81. And we're going to break that apart into 9 and 9. And we know that comes out to a series of 3's. I have a triplet of 3's. So keep in mind, I already have a 3 out front times my triplet of 3's, the cubed root of a leftover 3. A lot of 3's in that problem. So I'm going to simplify a little bit further from here. So the first term becomes negative 6 cubed root of 3, plus the second term will become 9 cubed root of 3. I can now add these together because they both have cubed root of 3. So if I add up negative 6 and 9, I get 3 cubed root 3, and that is my final answer. Last problem here in 36 is the exact same idea, except we're dealing with fourth roots. So just like we talked about before, fourth roots mean we need 4 of the same thing. So if I look at the first term here, if I try to do fourth root of 2, 2 doesn't break down at all. So I'm just going to draw a big arrow and pull it down, because I know I'm not going to have to do anything with it. The second one, however, fourth root of 162, there's a good chance it's going to break apart, and it will. So we're going to leave some space here and break that down. So 162 breaks apart into 2 and 81. We already established 81's 9 and 9, which gives me a whole bunch of 3's. Again, it's a fourth root, so I need 4 of a kind. I have one big 4 of a kind of 3's. So I'm going to pull that 3 out. Fourth root of what's left over, the 2. Now I'm able to subtract these together because they both have a fourth root of 2. Make sure not to make a goofy math mistake here. It's not 3 minus 3. It's negative 3 minus 3. This is going to become negative 6 times the fourth root of 2. So that concludes the video recap, if you will, all the explanations of the 7.1 through 7.3 quiz review. Again, for your quiz tomorrow, you need to make sure that you know how to punch in all the different things we talked about in your calculator. definitely study your properties. There again, it'll be more heavy on the radical stuff than anything else, but you do need to know some of your exponent properties as well for sure. This will be a little bit bigger of a quiz just because there's a lot of different components with it. Point value wise, we're looking for something in the mid 30s here. So do make sure that you look at this stuff. If you have questions, send me a message on Schoology. I'll do the best that I can to get back to you. And we will hopefully figure some stuff out from there. But be ready for this tomorrow. If you need anything, again, shoot me a message. We'll figure some stuff out. Otherwise, good luck with your quiz on Friday.